All right, evaluate logarithms using the change of base rule. So our first question says evaluate the logarithm. Round your answer to the nearest thousandth. So make sure you round correctly, because you can get the wrong answer if you do anything else right, but don't round right. So the question reads 5 times log of 48 with the base 2 is approximately equal to what? All right, so to do this, we first need to revisit this. And if you look at the question, we're going to end up using power rule. We have a 5 times a log. And here, the power rule, we have p times a log. So we're going to move this p as to an exponent on top of our x. So it'll be 48 to the 5th power. I have the question written down right here. All right, so this is 5 times. We're going to move this 5 from here to here. So rewrite it log base 2, and it's 48 to the 5th power. All right, you can evaluate that if you want, which would be 48. Here's your caret to the 5th power is a very large number. Let's say about 254,803,968. So instead of typing out all 9 of these digits, I'm going to just leave it like that. That's easier. Now, to evaluate this, we have to do something called change of base, which is also back in here. So you can see down your change of base. We can rewrite any log as 2 other logs with the x on top of the a, and we can pick our base. This is really helpful. I'll show you why right now. So let's put this problem aside for a minute. Let's go to, let's say, log base 2 of 4. All right, this equals something. Well, we know what logs are, so this is asking 2 to what power equals 4. We know the answer is 2. Well, we can also rewrite this using the change of base rule as a log of 4 over a log of 2. And we can pick any base we want. We could pick 2 again. We could pick 3. We could pick 4. The base that we're going to want to pick most often is 10. And the reason why I want to use 10 is because in our calculator, we have a log button right here. Oops, you guys can't really see that. There you go. There's a log. And that is using the base 10 right here. Whenever I hit log, you see how there's no base up here? Every single time you see this, it's assumed that it's a 10. So if I just wrote log of 100 equals something, well, if I didn't write a base, you assume it's 10. So the question would be 10 to what power is 100? It's 2. So let's check that. So if I put in log 100, it turns out to be 2. Okay? So I can also check this over here. I can do log 4 over log 2. So log 4 divided by log 2 should equal 2 as well. And there it is. Okay? So this is really helpful for problems like this that we don't really know the answer to. So we're going to rewrite this problem as log of this number, which is 48 to the 5th, all over log of 2. And once again, that's just using the change of base right here. It's this guy. And this can be any base we want. We're going to leave it as 10. So I can write it if I want to. I don't have to write it if I don't want to. So now we're going to do it in our calculator. So log of 48 to the 5th power divide by log of 2. And that turns out to be 27.9248. We want to round to the nearest thousandths, which this is going to round up, so we get 925. So 27.925. All right, next question. Okay, so we have log of 42 with base 6 is approximately equal to what? All right, well, this is actually a little bit easier. We don't have anything out in front to move, so we just have to do change of base. So we have our big number here, which goes on top. Log 42 over log 6 is approximately equal to what? Well, log 42 divided by log 6 is 2.086, and there's a 0 here, so we don't have to round anything. So it's just 2.086. Excuse me. Next question. All right, looks like a pretty easy one again. We're not having anything out in front. So log 0.2 with base 3. So here it is. Rewrite that as log 0.2 over log 3. Plug it in. Log 0.2 divided by log 3. We get negative 1.4649. So this 9 right here is going to make my 4 turn to a 5. So negative 1.465. 0.465, yeah. So negative 1.465. And last question. All right, once again, an easy one. Log, this looks similar. Did we just do this one? Yeah, we did, didn't we? Yeah, we just did this one. So we got lucky. It's the exact same answer. Negative 1.465. Okay, that one's done.